What is going on, guys? It is your average programmer here, back again with another video. I know it's been 2 weeks since I've uploaded my last video. I'm sorry about that, but my excuse is that I've been trying to learn some new things that I can teach you guys. And today I've got something very special, a very special video for you guys. So I hope you guys can forgive me after watching this video. So today's video is going to be about recursion. It's not going to be completely based on recursion, but we're going to create a console application that has to do with recursion. So when I run this application here, you can see that the application prompts you to type in a number, any number. So let's go ahead and type in 7. It says, oops, looks like 7 could not be found in this array. So as you can see, we're calling a method that takes in a parameter of an array and also a search value. And then inside of that method, it calls itself again to repeat the same line up here. And that exactly is what recursion is. That's exactly what recursion is. As you can see here, we're going to type in 55. I believe 55 was in it. And there you go. 55 is index 1. So we're going to go ahead and jump into our Visual Studio here and go ahead and code it up. I'm going to be walking through every step line by line and showing you how to use recursion in linear search to create this console application. Let's go ahead and, oops, my bad. Let's go ahead and skip out of that. So let's create a new console application, new project. I hope you all are doing all right. Make sure you guys are staying safe. We're going to call this recursion. Let's go ahead and create that. So as you see here, the project is being loaded up. Let me fix this mic really quickly. All right, that is much better. So let me go ahead and zoom in here so you guys aren't straining your eyes. All right, so this is the main method over here. We're going to create a method right below this method. We're not going to create a new class for this because it's not very necessary. So we're going to create a method down here, and we're going to call it find index, because that's exactly what we're doing. We're going to find the index of the value that the user types in. So we're going to make this a static method. We are going to return nothing. We're going to call it find index. So first we're going to do it without recursion, and then I'm going to show you how you can implement recursion into this method. Find index. As you can see here, we are going to take in a parameter of an array of numbers, array, and also, and I'm going to take in value. This is the value that we're going to search for in the array. So we're going to start off with declaring the index, because that's what we're keeping track of. That's what we want to find. We're going to set it to 0 to begin with. And then we're going to have to do something with this array. We're going to iterate through this array using, of course, the most prominent loop, which is a for loop. So we are going to go ahead and say, let me give this some space, make it look a little better. Int I equals 0. We're going to declare I, set it to 0 initially. And we're going to compare it to the length of the array. So as long as I is less than the array that we're passing in dot length, we want to increment I. Now we're going to jump into this loop. And this is where we're going to have all of our statements. We're going to use if statements, and we are going to compare the value to each value at the specific index of the array. I hope that makes sense. I want to explain it more as I go on, but for now, that's what it's doing. That's what we're doing. So we're first gonna have a Sentinel value here. If you don't know what a Sentinel value is, it's basically a value that ends your program. And the value that ends our program is gonna be 000. It could be any value you want, but I'm going to set it to 000 just because, I don't know, it's stupid. value, if value is equal to 3 zeros, or if it's equal to null, so if the user doesn't pass in anything, then we're going to go ahead and, let me redo this. We're going to go ahead and console.writeLine. I'm going to write out to the user what is going on. Write line. I'm going to write to the user that the program has ended. Has ended. And we are going to return the control to the main program. So if the user types in, excuse me, if the user types in a 000 or the user doesn't type anything in, we are going to end the program. We're going to tell the user that the program is ended. Fix this H. Else, if we come upon this value at index 0, remember our index is still 0 up here. Index is still 0, or if the first value is at index 0 at array I is equal to the value that we pass in. So if this first value that we're on, and as you can see, we start at 0 because I is 0. So if array of 0 equals the value that we pass in, we are going to console.writeLine. We're going to use some string interpolation here. The index of, then we're going to write in our value here. The index of whatever value is passed in is, I'm going to say index. The index of whatever value we pass in is going to be the specified index, or the index that we're on. And then we're going to break out of this because we just want to return this to the user and that's it. We're going to break out of this loop. Else, if that's not true, so if the first index is not equal to, or the first value at the first index, if the first value at that specified index is not equal to the value that we pass in, then we want to increment index plus plus. So now here's where things get a little complicated. So we've got our if statement up here. This is a statement that declares whether the user types in the Sentinel value, which is 000, or if they don't type in anything. So if those two statements are true, if either of those two statements are true, we're going to console.writeLine, the program has ended. Then we're going to return control back to the main program. Else, if array I, which is 0, equals the value, we want to console.writeLine, the index of whatever value we typed in is whatever index we're on. In this case, it's 0. And then we want to break out of this statement. Else, so this is our alternative statement, we want to increment index, which is our linear search. So we're going to go to the next index. And so if we happen to, let me go ahead and type in the statement before I say anything. Array I is not equal to value. We are going to console.writeLine. Console.writeLine. Oops. Select. I'm supposed to put this in strings. Let's go ahead and do string interpolation here. Like value is not in this array. All right, so let me zoom out a little bit here. As you can see here, so if the value at index 0 is not equal to the value that we pass in, we want to increment index. We're going to keep incrementing index for as long as we're still in the bounds of the array. We're still within the boundaries of the array. Basically, we haven't surpassed the length of the array. So we also go in here, and this statement right here says that if the index, which is this right here, this variable right here, the index is equal to the length of the array, which means we're at the end of the array, and we haven't found that value, which is what this means. If array I is not equal to value, then we want to console.writeLine this. It looks like the value is not in the array. So again, we're going to keep incrementing index for as long as index is within bounds of the array. But if index happens to be the length of the array, which is the last value of the array, and we still haven't found the value, then that means the value is not inside of the array. So we're going to console.writeLine this. I'm going to break out of here with a simple break keyword. Break. Now that's it. And we haven't used any recursion yet. This is just plain linear search. And we're going to go ahead and work with this for now. And again, I'm going to show you recursion in a little bit after we go ahead and see if this works. So we're going to declare an array. Let's say random array equals new int, new array. We are going to pass in the values 80, 45, 67, 1, 35, 22, 74, 14, 10. These are just random numbers. And we are going to call our find index method. And in here, of course, as you can see, we're going to pass in an array and a search value. But first, or actually, yeah, let's go ahead and pass in the array, which is our random array. Array, and then our search value. Here's what we're going to do for that. We're going to prompt the user. And we can do that by console.writing, by using the console.write method and prompting the user. So let's go ahead and type in the value you are searching for. Type in the value you are searching for. And we're going to take that, we're going to call it n, which is the number that we type in, equals, of course we have to convert it to an integer because anything you pass in to a console.write is actually a string. So we're going to convert it to an integer and we're going to read the line. Console.readLine. And we're going to pass in this n. So basically that's the input that the user types in. We're taking that input and passing it into here. Let's go ahead and see. So we've got this array right here. We're going to type in a value that is in here first. So we're going to type in 67. Let's go ahead and count 0, 1, 2. 67 is at index 2. So let's go ahead and see if we're right. Go ahead and control F5. We're going to type in 67. Perfect. The index of 67 is 2. So that works. And we broke out of our program. So let's type in a value that is not in here. Let's go ahead and type in 100. 100. Boom, there we go. Oops, it looks like 100 is not in the array. So our program is working without recursion at all, just plain linear search. So now we're going to implement some recursion in here just so we don't have to rewrite this method over, because we want to continuously prompt the user for value for as long as the value is not this Sentinel value over here. And let's go ahead and try that while we're at it. So control F5, we're going to type in 000. And we've written out to the user, the program has ended, and I do not know how to spell. Let's go ahead and change that in here. Program, not program. Program, perfect. So now let's go ahead and implement recursion. So how could we implement recursion into here? The simplest way that we can do that is basically, so we know we've taken an input from the user, we've passed it in, and we've gone through the algorithm that we created here. So the best place to implement recursion would be at the end of this, because we don't want to prompt the user twice before actually going through the algorithm. If we put our recursive statement at the front, then it's going to prompt the user 2 times before we actually go through this algorithm. So which is why we want to actually take this. So if we were to put this in here, let me go ahead and show you. If we were to put it at the beginning, I wasn't supposed to do that. Copy. If we were to put this at the beginning, we're going to see what happens. It's going to prompt you 2 times before actually pass an array, because that is the scope. It's going to prompt you 2 times before it actually runs through the algorithm, which doesn't make any sense. And as you can see here, it prompts you twice, which doesn't make any sense before it actually goes through the algorithm. Actually, it prompts you several times, which is not good. We do not want that to happen. So we're going to take these statements and put it at the end of our method. So let's see here at the outside of the for loop. Be sure it's on the outside of the for loop. And now let's go ahead and see if this works. So let me check first. So we passed an end to here inside of our method. We've got that value equals null. I take in. Okay. Looks like this works. So let's go ahead and try this. This is recursion. Recursion is basically when a method calls itself. So here we're implementing recursion. So this method is going to call, then it's going to go through this algorithm, and then it's going to prompt the user at the end of the method call, and then it's going to call itself again, and then it's going to go through the algorithm, prompt the user, and call itself again continuously. So it's nonstop, it's continuous. But good thing we've used this Sentinel value, which allows us to break out of that recursive statement. If not, this recursion would occur constantly, which is what recursion is. It's when it's constantly calling itself with no end. But good thing we've added a Sentinel value, which is 000 or null. So we can actually break out of this recursion. So let's go ahead and fire it up. Type in the value you are searching for. Let's type in a value that is actually in it. So let's say 35. So let's count 0, 1, 2, 3, 4. Index 4 we should get back. 35. Perfect. The index of 35 is 4. And then you can see the recursion is here because it's prompting us again. Before, it wasn't prompting us for another value. All it did was end the loop, and all it did was return the control back to the main program, which basically ended the entire program. But now we're prompting the user again after we go through the algorithm. So let's type in a value that's not in it. Let's type in 100 again. And again, oops, it looks like 100 is not in the array. And again, you can see the recursion here. We're prompting the user again for a value. So it looks like our recursion works, and that is basically the general idea of recursion. And as you can see, we've implemented recursion in our application. We've used linear search and recursion inside of this application. And I'm not sure if I mentioned what linear search is. It's basically searching through something from one end to another. Basically goes through some kind of collection from one end to another, searches through it, searches through each individual value. That's what linear search is. And recursion, again, is when a method calls itself, which is what we're doing. So we call the find index method in our main program. It runs through this algorithm. Then it prompts the user again for an input. Then it calls the method again, and it does it nonstop, goes through the algorithm, so on and so forth. So let's go ahead and try this one more time. Or sorry, let's go ahead and try a value that, well, we did try a value that's not in. We're going to go ahead and use our Sentinel value. That's what we're supposed to do. So the Sentinel value does not call the recursion again. And we're going to see here, 000, the program has ended. No recursion. It's not prompting the user again for any input because we've used that as a Sentinel value, which breaks out of the recursion. So that's the basic idea of recursion again. I really hope you liked this video. If you did like it, be sure to hit a like and subscribe if you want to stay tuned for more. I've got plenty more content coming, and hopefully I made up for my lack of presence on YouTube. I hope you all have a great day. Take care and be safe. Peace.